Welcome, everyone. I'm excited to welcome you to today's presentation on cognitive load and neuroplasticity. Today, we'll explore how our brains process and improve memory. The presentation is titled Memory Mastery Foundations, and will cover key concepts like short-term, long-term, and working memory, as well as how encoding, storage, and retrieval work together. We'll also look at how focus influences our understanding and how neuroplasticity helps us strengthen our memory systems. I look forward to guiding you through these fascinating topics. Let's get started. Memory is a dynamic system that involves more than just storing information. It's about encoding, which is how we initially take in data, storage, where that data is kept over time, and retrieval, which is how we access it later. Modern neuroscience has shown us that memory isn't a static record like a photograph. Instead, it's a flexible and reconstructive process. Our memories can change and adapt based on new information, attention, and emotions. This means that how we remember something can be influenced by what we focus on and how we feel at the time. Understanding these aspects helps us see memory as a living, breathing part of our cognitive system, one that's shaped by many factors and constantly in flux. This idea ties directly into the overall theme of how our brain processes and preserves our experiences. Let's take a closer look at the three key processes that form the foundation of memory mastery. First, retrieval. This is all about accessing stored memories when we need them, like recalling a fact or a past experience. It's the moment when our brain pulls information from storage. Next, we have storage itself. This is about retaining information over time, making sure that memories are preserved so we can access them later. And finally, encoding, which is the process of transforming sensory input into a format that our brain can understand and store. These three stages, retrieval, storage, and encoding, are the core pillars of how we manage our memory. Understanding these stages helps us see how memories are formed, maintained, and accessed, which is essential for developing better memory skills overall. Let's explore how semantic processing actually leads to better recall. When we talk about depth, we're referring to the idea of linking new information to what we already know. This connection makes the new material more meaningful and easier to remember. Association plays a key role here. It involves converting raw sensory data, like sights and sounds, into neural codes within our brain. Think of this as translating what we perceive into a language our brain understands. The input is the raw sensory information we receive, and the mechanism is how our brain processes and transforms this data. This transformation is what we call encoding. It's the process of turning this information into a form that can be stored in our memory. So, overall, effective encoding through semantic processing enhances our ability to recall information later on by creating richer, more connected mental representations. Let's explore how our memory processes operate across different time scales, from just seconds to several decades. When we talk about sleep, particularly during REM stages, it's fascinating to see how the brain replays patterns of activity. This replay isn't just random. It helps reinforce what we've learned and experienced. Now, this replay plays a crucial role in strengthening the neural connections that form our memories. Think of it as a workout for your brain. Repeating these patterns makes the connections more robust and durable. Additionally, during this process, the brain actively maintains and keeps encoded information accessible. This active maintenance is key to retaining what we've learned, especially right after we acquire new information. Finally, all these processes, replaying patterns, strengthening connections, and active maintenance, are essential for storage and consolidation of memories. Over time, these mechanisms help transform fleeting experiences into lasting memories, supporting our ability to recall information even years later. This interconnected process underscores the importance of sleep and active engagement in learning for long-term memory retention. Let's explore how active recall actually works to strengthen our memories. When we actively retrieve information, it helps to reinforce the neural pathways associated with that memory. Think of it as making those pathways more durable, so they're less likely to be forgotten in the future. But it's important to remember that memories aren't just replayed like a tape recorder. Instead, they are reconstructed each time we recall them. This means that our memories are influenced by the context in which we're trying to remember, which can sometimes alter what we recall. Now, when it comes to successful retrieval, it's not just about practice. It also involves the right context and cues. Practice, combined with the right environmental or situational cues, helps us access the memory more effectively. So, retrieval, getting that information back, relies on this interplay. Practice, context, and cues all work together to make the act of retrieving memories more efficient. This is the core idea behind how we strengthen our ability to recall information over time. Today, I want to talk about the importance of chunking information into meaningful units. When we're trying to remember or process data, breaking it down into chunks helps our brain handle it more effectively. A good strategy is to give yourself about 20 to 30 seconds without rehearsal, allowing your mind to organize and encode the information naturally. In terms of capacity, Miller's law suggests that our short-term memory can hold about 5 to 9 discrete items at a time. So, when designing presentations or learning tools, keeping information within this range makes it easier for your audience to absorb and retain it. This leads us to the concepts of capacity and duration in short-term memory. Capacity refers to how much information we can hold, while duration is about how long that information stays accessible without active rehearsal. Both are crucial when trying to communicate effectively and ensure your message sticks. Remember, by chunking information into meaningful units, you're leveraging our natural memory limits to enhance understanding and retention. Let's take a closer look at the key aspects of long-term memory. First, salience. This refers to how emotional events tend to be encoded more deeply into our memory. When something really moves us or has strong emotional significance, we're more likely to remember it vividly and for a long time. Next is capacity. Our brain's storage for long-term memory is virtually unlimited, allowing us to retain information from just days to even decades. It's quite remarkable when you think about the vast amount of experiences and knowledge we can hold over a lifetime. Now let's talk about the types of long-term memory. There are two main categories, implicit and explicit. Implicit memory involves unconscious skills and conditioning. For example, riding a bike or typing on a keyboard. These are skills we perform without actively thinking about them. It also includes conditioned responses, like feeling anxious when you see a spider if you've been conditioned to fear them. On the other hand, explicit memory is conscious. It includes facts and knowledge, what we know as semantic memory, and specific events, which we refer to as episodic memory. Semantic memory might be knowing that Paris is the capital of France, while episodic memory involves remembering your last vacation there. All of this fits into the broader concept of long-term memory, which is essential for shaping who we are and how we navigate the world. It's fascinating to see how these different types and features work together to form our rich, personal tapestry of memories. Let's take a closer look at the core components of working memory. First, we have the episodic buffer, which acts as an integration point, combining information from different sources into a coherent episode or story. It helps us create a unified experience from visual, auditory, and other types of data. Next is the visuospatial sketchpad, which is responsible for handling visual information, like images, spatial layouts, and mental maps. It allows us to visualize scenes and navigate through space mentally. Then there's the phonological loop, which deals with auditory information, like sounds, words, and speech. It's what enables us to hold onto verbal data temporarily, crucial for language processing and learning new words. At the center, we have the central executive. Think of it as the attention control system. It directs resources, manages focus, and coordinates the activity of these subsystems. It's essential for reasoning, problem-solving, and learning. Together, these components form the active processor of working memory, helping us understand, learn, and adapt by managing different types of information efficiently. They're interconnected, working seamlessly to support our cognitive functions. Now, let's take a closer look at the different types of mental effort involved in learning. First, we have germane effort, which is the effort used to build and develop schemas. This is really the productive effort that helps us organize and understand new information more effectively. Then, there's extraneous effort, which comes from poor design or distractions that make learning more difficult than it needs to be. This kind of effort doesn't contribute to understanding. Instead, it wastes our cognitive resources. Lastly, we have intrinsic effort, which relates to the inherent complexity of the topic itself. Some subjects are naturally more challenging, and that requires more mental effort to grasp. Understanding these different types of effort is essential because it helps us design better learning experiences. When we minimize extraneous load and manage intrinsic load, we can free up cognitive resources for germane processing, leading to deeper learning. This ties directly into the broader theme of cognitive load theory, which emphasizes the importance of managing mental effort to optimize learning outcomes. Now, let's explore how we can effectively support learners, especially novices, by providing step-by-step guides. One powerful approach is through worked examples, where we demonstrate each step clearly to build understanding. Breaking complex tasks into small, manageable parts, often called segmenting, helps prevent cognitive overload and makes learning more accessible. Another key strategy is combining words with relevant visuals, a concept known as dual coding. This approach leverages both verbal and visual channels in the brain, reinforcing learning and making it easier to grasp difficult concepts. So, how does this all work together? By managing cognitive load, we help learners process information more efficiently. These strategies are designed to scaffold understanding, making complex content less intimidating and more approachable. Ultimately, this aligns with the overall goal of creating effective, learner-centered instruction that promotes comprehension and retention. Let's talk about how we can effectively design learning experiences by gradually increasing task difficulty. This means starting with simpler tasks and then progressively making them more challenging, helping learners build confidence and skills step by step. Next, scaffolding is a key principle, providing support structures that guide learners through complex concepts. Think of it as offering just enough assistance to help them succeed without doing the work for them. When we pair concise text with diagrams, we make ideas clearer and more memorable. Visuals can simplify complex information and engage learners more effectively. Using multimedia is another powerful tool. Incorporating videos, audio, and interactive elements can cater to different learning styles and keep engagement high. It's also important to present one concept at a time. Focusing on a single idea prevents overload and helps learners process information more thoroughly. Chunking involves breaking down information into manageable sections. This helps learners absorb and retain content more easily, avoiding overwhelm. Finally, application is essential. Encouraging learners to apply what they've learned through practice solidifies understanding and promotes transfer of skills to real-world situations. All of these principles, scaffolding, visual pairing, multimedia, focusing on one concept, chunking, and application, work together to create effective learning experiences that are engaging, manageable, and meaningful. All right, let's talk about how spaced and varied practice can actually help reduce overlap in learning. When we space out our practice sessions and vary the types of practice, it becomes easier for our brain to distinguish between different pieces of information. This approach helps prevent confusion or interference between similar concepts. Now, moving on to solutions, one key idea is that new learning can disrupt old learning. For example, if you get a new phone number, it can temporarily push out your old one from memory. This is called retroactive interference. Conversely, old learning can also interfere with new learning. Think about how remembering old language rules might make it harder to learn new grammar structures. This is proactive interference. Both types of interference involve competing information, your brain's way of managing multiple similar pieces of knowledge. Recognizing these patterns helps us develop better strategies for learning and retention. And, as we've seen, spacing and varying our practice can be powerful tools to minimize this interference and improve long-term learning. Let's talk about periodic review and retrieval practice. These are key strategies to help prevent memory loss. When it comes to prevention, the loss of information is usually low, because it's often just an access issue rather than a true loss of the memory itself. So, if you can find a way to reconnect with the information, you can usually restore it quite easily. Now, in the long term, the risk of forgetting increases significantly. Without rehearsal or review, information can be lost in seconds. That's why regular review is essential for durable learning. In contrast, short-term memory decay happens quite quickly. This is where the impact of decay theory comes into play. According to decay theory, memories fade over time if they're not actively maintained through rehearsal. So the key takeaway here is that the type of memory, whether short-term or long-term, affects how quickly we forget and how we should approach review. For long-term retention, consistent review and retrieval practice are crucial to keep information accessible and prevent decay. So, one of the key reasons we forget information is because we're missing the right triggers or associations that help us access that stored data. Think of these cues as clues or hints that lead us back to the memory. Without them, it becomes much harder to retrieve what we know. Recall is also influenced by the environment in which we try to remember. If the testing environment is different from where we originally learned the material, it can make recall significantly more difficult. This is why context plays such a vital role in memory retrieval. Now, a large portion of forgetting, about 80%, is actually due to retrieval failure. This means the information is still stored in our memory, but we just can't access it at that moment. This phenomenon is called retrieval failure, and it's a common reason why we sometimes forget things, even when we know the information well enough to remember it under the right circumstances. So, in essence, forgetting isn't always about losing the information. Often, it's about not having the right cues at the right time. Memory is a skill to be built, not a fixed trait. What that means is that our ability to remember and learn isn't set in stone. It's something we can develop over time. The concept of malleability is really key here. Our brains are capable of change at any age, not just during childhood. This idea of lifelong learning and adaptation is central to understanding how our brains work. Brain reorganizes itself by forming new connections, which is what we call neuroplasticity. This process allows us to adapt to new experiences, learn new skills, and recover from injuries. It's a biological reality, meaning it's grounded in how our brains are wired and how they can change throughout our lives. So the big takeaway is that memory and learning are dynamic processes. They're not fixed abilities, but skills that we can strengthen and refine through effort and practice. This ties into the overall theme that our brains have incredible potential for growth and change, no matter our age. Let's talk about how mindfulness and cognitive tasks actually boost our brain's adaptability. When we practice mindfulness or challenge ourselves mentally, we're encouraging our brains to grow and change, which is a key part of resilience. Resilience, after all, is about bouncing back and adapting to adversity, and a flexible brain makes that possible. Now, exercise and facing challenges do more than just improve our physical health. They also increase certain proteins that help grow new neurons. One of these is BDNF, or brain-derived neurotrophic factor. Think of BDNF as a fertilizer for your brain cells. It promotes the growth and survival of neurons, which is essential for learning and memory. Finally, when we repeatedly recall information or practice skills, we're actually strengthening the connections in our brains, what we call pathways. This process is known as long-term potentiation, or LTP. Essentially, the more we reinforce these neural pathways through consistent practice, the stronger and more efficient they become. So, in essence, learning physically changes our brain by making these pathways more robust, which is a fundamental part of how we acquire and retain new skills and knowledge. All these points underscore that our mental activities and lifestyle choices directly shape our brain's structure and function. supporting overall resilience and cognitive health. Let's talk about some measurable improvements in recall performance that we've seen. When individuals adopt a growth mindset, there's a noticeable increase in their willingness to use challenging active recall tools. This willingness to persist, even when the tasks are difficult, is a key factor in improving memory. Viewing memory as something that can be improved actually encourages people to put in more effort. It shifts their perspective from seeing memory as fixed or unchangeable to seeing it as something that can be developed with practice. This mindset, believing that effort leads to improvement, has a powerful impact. It influences not just how much effort someone is willing to invest, but also how they approach learning and memory tasks overall. And that's really at the heart of the growth mindset. When we see our abilities as adaptable, we're more likely to persist through challenges, which ultimately leads to better memory performance. So, fostering this growth mindset can truly make a difference in how we approach learning and memory, leading to sustained improvements over time. All right, now let's focus on identifying your strengths. This is about understanding whether you learn best through visual, auditory, or kinesthetic methods. Think about which style resonates most with you. Are you someone who learns best by seeing information, like charts, diagrams, or images? Or do you find that listening helps you retain information better, like lectures or discussions? And perhaps you're more of a hands-on learner, needing to physically engage with the material to really understand it. Recognizing your preferred learning style is a key step in customizing your approach to studying and absorbing new information. It connects directly to the overall theme of maximizing your strengths to become a more effective learner. So, take a moment to reflect on which of these styles suits you best, visual, auditory, or kinesthetic, and use that insight to enhance your learning strategies. All right, let's walk through this memory recall practice. First, we start with step 1. Study 15 words for about 2 minutes. This initial phase helps us encode the information into our memory. Then, in step 2, we try to recall those words after different time intervals, specifically after 10 minutes, 1 hour, and 24 hours. This allows us to see how well the memory holds up over time. Finally, in step 3, we track the results to identify any decay patterns. By doing this, we can determine whether the issues with recall are due to encoding problems or retrieval issues. This insight is crucial because it guides us on how to improve our memory strategies, whether we need to focus on better encoding or on strengthening retrieval. Remember, understanding these patterns helps us optimize our learning and retention processes effectively. Let's take a look at some effective tools for self-testing and organizing your learning. Quizlet is a fantastic platform for self-testing because it allows you to create flashcards and quizzes that reinforce your knowledge. Notion, on the other hand, is great for mind mapping, helping you visualize how different concepts connect and organize your ideas clearly. Anki utilizes spaced repetition, which is proven to improve long-term retention by reviewing information at optimal intervals. These tools are essential components of our overall strategy planning because they help you actively engage with the material, reinforce your understanding, and plan your study sessions efficiently. Incorporating these tools into your learning routine can significantly boost your retention and comprehension, making your study sessions more effective and strategic. Now, let's talk about some practical strategies for maintaining and advancing your skills. Contextual switching is a key concept here. It's about shifting seamlessly between different tasks or techniques as needed. To support this, tracking your weekly progress helps you see how far you've come and identify areas for improvement. Daily practice is essential, and I recommend focusing on 2 to 3 techniques each day to build mastery without feeling overwhelmed. Looking ahead, the next steps involve integrating these practices into your routine consistently and exploring how they can be applied in real-world situations. Practical applications are where true growth happens, so I encourage you to think about how these techniques can be used in your daily work or personal projects. Remember, the goal is to make these skills second nature, allowing you to adapt fluidly and confidently in any scenario. Memory is a skill, not a trait. That's a really empowering idea because it means anyone can improve their memory with practice and effort. It's not something you're just born with or without. It's something you can develop over time. So I encourage you to start your mastery journey today. Think of your brain like a muscle. The more you train it, the stronger it becomes. And that's what we're here to do, train our brains to remember better, faster, more efficiently. Remember, mastering memory isn't about being perfect. It's about making steady progress. Every small step you take adds up to significant improvement. So, I invite you to embrace this mindset and take action now. Start today and watch how your memory transforms. Because in the end, memory is a skill, and skills are meant to be learned and refined. Let's get started on that journey now.